Hey everybody, welcome back. Still talking about arc length and sector area. Um, in this first one, I talked about sector area. Here we're talking about arc length. Sorry, that's backwards. First one we talked about arc length. Now we're going to talk about sector area. So um, you may or may not have remembered or remember that the area of a circle is found using a formula pi r squared. That's a very well-known formula. This is almost never used with D, it's always used with R. So this one, R is the most important number in a circle. It like defines a circle in almost every way. Remember, R is from the center to the edge, not all the way across. R is half the distance across. So here's a couple little mini problems. Find the area of the circle. The only thing we need, if you look at our area formula, the only two unknowns are the area itself and R. So if I'm given the radius, area is pi times r squared. R is 9. So it's pi times 9 squared, which is 81 pi, because 9 squared is 81. We usually write the pi after the number if we have one. So, and I need a unit here. The distance is measured in meters. Since we measure area in units of distance squared, it's going to be meters squared here. 81 pi meters squared. And again, you could go in your calculator and multiply 81 times whatever the value of pi is stored in your calculator. That's going to be like 250 or 260 or something like that. But I'll tell you which one I want you to do. In general, I like exact answers better than rounded answers. So, and here's a similar question. Find the diameter of a circle with an area of 121 pi. And if I look here, this is my formula for area. This has A and R in it. And it says an area of 121 pi. So that goes where the A is. So I get 121 pi equals pi R, 121 pi. 121 pi is pi r squared. And like it says, find the diameter. And this is the radius. But if I find the radius, I can then find the diameter from that. Because as you may recall, the diameter is all the way across the circle and the radius is just halfway across. So when I solve this for the radius, I'm just going to multiply my answer by 2 to get the diameter. So we solve this in our usual way. We have pi times r squared. So I'm going to divide both sides of the equation by pi. And that pi cancels out with that one. This pi cancels out with that one. And I get 121 is r squared, which means that r is 11 because the square root of 121 is 11. Technically, it's 11 or negative 11 in this case, but I can't use negative 11 for the length of a radius. So just to finish the problem, it says find the diameter. Diameter is 2 times the radius. So D is 2R, which is 2 times 11, which is 22. And there's no units here. So if this is said 121 pi square inches, then this would be measured in inches. Was that 121 pi square miles, then this would be in miles. So remember, distance is measured in like units of distance, and area is measured in units of distance squared normally. That's how we found areas of circles. And we can also, given this formula, if I give you R, you can find A, but if I give you A, you can find R. And in this problem, we can find D. So before we looked at the area, we looked at the circumference, and then we were like, that's the distance all the way around the circle. And then we looked at what might be the distance around part of a circle. And similarly, this is the area of the entire circle, but what if I just want an area of a piece of the circle? Well, you could imagine what that might look like. Pretend like that's the center. And like here is like a piece of the circle, this piece right here. And this thing is called a sector. Sector. This chunk here is called a sector. The area of a sector is usually, the variable we normally use is K. I don't know why, but it's usually used, we use a K. And let's say that this sector is like, you indicate the sector, there's some angle in here, which again, I'm going to call theta. Remember, this circle has some given radius, r, and there's theta, and the area of this sector is called k. So the way we find the area of a sector is very similar to how we find the how we find the length of an arc. The formulas look really similar. So we're going to set up a proportion again. And this side of the proportion is exactly the same as the other proportion, theta over 360. If you remember, our proportion for arc length was s over 2 pi r equals theta over 360. This one, though, it's k over pi r squared. And it's like, if you just, we can kind of get a handle on this. 2 pi r is the length all the way around the circle, and s is part of the length. And this is like the entire area of the circle, and this is part of the area. There's like a thing going on in these proportions, which is like, they're all part over whole. Like this is part of the area over the whole area, and this is part of the angle, part of the central angle, and this is the entire angle. If I go all the way around the circle, it's 360. So like there's should you memorize these formulas? Maybe. What you should do is like understand why they are the way they are. Part over whole equals part over whole. Theta is part of the angle. 360 is the whole angle. K is part of the area. Pi r squared is the whole area. So just like before, if we think about what we don't know in this little proportion, there are three things: K, R, and theta. So for these problems, because this is how algebra works, I'm going to have to give you two of these and have you find the third one. So in this case, it says find the area of the sector. The sector is the thing that's darkened in here. So the area of this thing, I can use the proportion to find it. So I'm just going to write the proportion again, just so I have it to refer to. Pi r squared equals theta over 360. And again, this is the one, I should write this up here. This works when theta is in degrees. Since theta is measured in degrees here, I can use this formula. I'm going to plug in everything I don't know. I'm going to plug in everything I know. I don't know K, so I'll leave that as K. I do know R is 3 meters, so this is pi times 3 squared. I know theta is 150 because it's right there. This is over 360. And as in the previous ones, I think it's easier to reduce the fraction here on the right, if you can, before you start manipulating this thing. So 3 squared is 9 on the bottom here. So 9 times pi is 9 pi. Let's see, 150 over 360, I think it's 5 over 12. Yeah. We both divide by 30. Yeah. So I get K over 9 pi equals 5 over 12. And just like before, since this is the thing I'm looking for is divided by a number, I like imagine multiplying both sides of the equation by that number. The 9 pi and the 9 pi cancel out, which was the whole point of doing it that way. And I get 5 over 12 times 9 pi. 5 times 9 is 45. So it's 45 pi over 9. This fraction can also be reduced. They both divide by 3. Oh, 45 divided by 9 is actually just 5. So this is just 5 pi. And that should be measured in meters squared. Squared area. Meters have to be squared for area. So yeah, that's how we use this formula. Very similar to how we use the previous formula. You just got to make sure that you're using the right one. Like I said, since it says area here, it's like a big hint that this should have a pi r squared on the bottom, but not a 2 pi r, because it says area. And here's a couple more little problems, then we'll be done. This one says find the radius of a circle if a central angle of 120 degrees cuts a sector with an area of 12 pi. So you don't have to draw a picture here, but I will just so we can remember what we're talking about. Here is a circle. 180 is like 120 is like about there, maybe. We imagine that this is our central angle theta, and it's 120 degrees. And the radius I'm looking for, they don't tell me that in this one, r equals something. And then they tell me that the area of the sector K is 12 pi. There's no units, so I don't have to worry about units at the end of this one. I'll do it the same way. I'm just going to set up my equation just like I did before. K over pi r squared is theta over 360. K, this time I know it's 12 pi. I don't know r. That's what I'm trying to find. So I'll just rewrite pi r squared here on the bottom. Theta is 120, so I get 120 over 360. And now I'm going to have to figure out how to solve this thing for r. It's kind of caught up in a bunch of different things. It's like on the bottom this time and it squares, so there's going to be a little more work to get to it, but I can do a lot of simplifying before I get there, which will make this a lot easier. One thing I can do is I can cross off the pi's on the top and bottom. Pi divided by pi is 1, so those disappear. And I actually know that 120 goes into 363 times. So 120 over 360 is really 1 over 3. So I'll rewrite that proportion one more time. 12 over r squared. Now I crossed off the pi's. And 120 over 360 reduces to 1/3. So now we come into some like issues maybe with like solving this. You can't multiply both sides by 12. That's not going to make the r squared is on the bottom here. So you can't multiply both sides by r squared to make it go away. But there's more than one way to do this. I know that I can do what we always call cross multiplying in math, which is r squared times 1 equals 12 times 3. This times this equals this times this. That's just the way math works. And there's a bunch of ways you could multiply both sides by r squared and then multiply both sides by 3 or something. You get the same. You get this, like the same thing would come out of it. But I like to do it this way. R squared times 1 is r squared, and 12 times 3 is 36. So if r squared is 36, then r is equal to 6. Technically, r is plus or minus 6, but since we're talking about like a length here, the radius is a length. It can't be a negative length. And there are no units, so I don't have to put a unit if I don't want to. But if I was, it was going to be like meters or inches or miles because a radius is a length. So there you go. This is just an area question. I'm not sure why it's here, but we'll do it anyways, just for a laugh. We know that A is pi r squared. It says find the area. So I'm going to find the area. And so I need r, which is not given to me. But I do have 16 and 12 here. And since this is a right triangle, I know that the hypotenuse, the length of this side, can be found using the Pythagorean theorem. And since this side goes through the center, this length, whatever this is equal to d. And so when I find it, I can just divide it by 2 to find the radius and then plug that in here and get the area. So off to the side here, I'll figure out what r is. So the Pythagorean theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So I say 12 squared plus 16 squared equals, I'm going to call it d just because that's going to remind me it's diameter. 144 plus 256 is d squared. 144 plus 256 is 400. Square root of both sides gives me that d is equal to 20. And again, there's no units in this problem, so I don't have to worry about it. But if there were units, diameter is a distance, so it's measured in like feet or miles or kilometers or whatever, but it's 20. And what's important for this problem is not to find the diameter, but to find the radius. Diameter is 20, the radius is 10. So now I'm going to jump back over here. A is pi r squared and r is 10. A is pi times 10 squared, which is 100 pi. So this problem was kind of randomly in here, whatever. You just have to use the Pythagorean theorem to find the area, or sorry, to find the radius, and then you plug it in to find the area. But this is how we use the sector area formula. This problem here, given you finding the area, in this case, we were finding the radius. I could also ask you to find the angle if I gave you K and R. Hope this was a enlightening video for you guys, and we will do practice with this in class. Bye.